Okay, so we finished talking or last time or earlier today about polyatomic ions. Again, you do need to kind of know the list as we talked about and the formula and the names that go with them. As we talked about, there are several patterns that we do see with the polyatomic ions. So this is again one that we talked about where there's a group of four that are related to each other. And really, in a group of four, you could break them up by twos, and the two that have the least number of oxygens, as we talked about, will end in ite, and the two, obviously, with the most oxygens will end in ate. And we have the additional sort of starting to the name for the guy with the most oxygen, which is per, like we see here with perchlorate, and hypo for the guy with the least number of oxygens, which is in this case hypochlorite. So again, in that pattern of sort of four, in addition to ate and ite at how they end, we also put per and hypo. Again, per for the one with the most and hypo for the one with the least. And then kind of the middle two are just named like normal, like chlorate and chlorite. They don't have anything that comes before it. Now, as I mentioned as well, you can swap out, for example, anything like that, like BrO3 minus would be bromate, iodate if you put iodine in there. And as I also mentioned earlier, the other common thing that we see again is adding a proton or an H plus. And sometimes people, when they do that, don't realize again that the charge is affected. So you're not only just putting the H on, but you're also going +1 and -2, which leaves you a -1 left over. And again, that is called hydrogen carbonate, and is also very commonly still referred to as bicarbonate, like sodium bicarbonate and all that kind of stuff. So that sort of hydrogen is sometimes replaced in the name with bi. And again, the two common ones that you see that is bicarbonate, which is hydrogen carbonate, and bisulfate, which is hydrogen sulfate, basically. So it's sulfate with an H plus on it. So as we talked about in a group of two, or whatever it may be, ate and ite. And I said, a good approach to some people do take is, like I said, just sort of memorize one of those guys, either the ate or the ite, and just know that either you'll just put an oxygen on or take an oxygen off if you need the other one. Absolutely everything else stays the same. So the charge stays the same. The sulfur, for example, with sulfate and sulfite stay the same. It's just really the number of oxygens that change in these sort of polyatomic ions. So that's a good way to sort of group them together and sort of learn them that way when you do it. And then we got the per and stuff. Any questions on polyatomic ions? And as we saw in sort of a practical application of polyatomic ions, it really will, for the most part, end up a lot of times with a metal. So again, if it is a metal and a polyatomic ion, first off, those two things is an ionic compound. And it is always that metal that is most important. So again, you'll either have the type 1 metal, which does not need a Roman numeral, or you'll have the type 2 metal that does need a Roman numeral. And most importantly as well, if you have multiple polyatomic ions, you got to put the parentheses around them to indicate how many you have and the number on the bottom as well. So the last thing we're going to sort of talk about here is naming acids. And let me get rid of what's on my screen there, I guess. So naming acids. Acids are really substances that can produce H plus ions in solution. That's basically your definition of an acid, is basically the ability when it goes for a swim, basically to produce H plus ions floating around. And those are free H plus ions floating around. They also are sometimes equivalently called the hydronium ion H3O plus. Same thing. So in terms of acid-base chemistry, basically these two guys are exactly the same sort of thing. They both represent really the acid part of it. Now, when we go to name acids, it really all revolves around really one sort of element. It revolves around oxygen. And there are certain acids that contain oxygen, which are called oxyacids, because they do contain oxygen. They also usually will have that bond here, the OH bond, and it's that hydrogen there that comes off. That is what makes it sort of the acid. And there's basically acids that don't contain oxygen. And depending on whether or not there's oxygen involved as to how you go about naming it. So let's talk about really the two ways that we name it. So first off, if there is no oxygen in your acid, basically the acid starts with hydro something ic acid. The something here is basically the anion. They're the negatively charged guy. Because when we deal with an acid, say like HCl, couple of things. We do look at this, that the cation with every acid is H plus. So H plus is really the cation that's for every acid. And in this case, the anion here would be Cl minus. And it really is like an ionic compound. So positive, negative, we're going to equal 0. So in this particular case, there is no oxygen. So this would be hydrochloric acid. Again, the chloric coming from the non-metal here, the negative guy in this particular case. In addition, because really an acid is, like I drew here on this page, the ability to, in solution, break apart. Acids typically get the AQ symbol, which means aqueous. So we typically put AQ next to it. It basically means a water environment, it means a solution. It means that those ions are basically floating around in that solution. And that is how we know that is different than, say, HCl, which maybe is a gas, which somebody would call hydrogen chloride. So that is sort of the difference. Take hydrogen chloride, kind of bubble it through water, you get hydrochloric acid, which is the aqueous version of it. Basically, the H plus is floating around, the Cl minus is floating around in that case. So it is very common and good practice that when you write formulas for acid, you do put the AQ sort of symbol next to the formulas to indicate that it is the acid that you are dealing with. So that is the first rule there. If we got no oxygens involved, it will be hydro something ic acid. If we do have oxygen involved, it will contain one of those polyatomic ions. So if it is yes, we do have oxygen, it will have one of those polyatomic ions. And as we just saw and talked about, it ends in ate or ite, typically are polyatomic ions. And if our polyatomic ion ends in ate, oops, wrong way, come back. I'll do it up here so we can kind of see it. If our polyatomic ion ends in ate, the acid name will be something ic acid. If our polyatomic ion ends in ite, the acid name will be something OUS acid. So for example here, if we take HNO3, NO3 is nitrate, ATE, which means this is nitric acid. If we have something like HNO2, some of this here. So if I had something like HNO2 here, NO2 is nitrite, ITE, this would become nitrous acid, OUS. So a couple important things. If it has oxygen, it should not have hydro in the name. So it should not have hydro in the name. Hydro is just for acids that do not have oxygen. The way you can remember it is if you ate too much, you feel icky. So that is how the acid goes, right? So if it ends in ate, it will end in ic. And if it ends in ite, it will end in OUS. Again, in each of these cases, the cation is H plus. And the anion in this case would be nitrate. Also why we just need one of the H pluses, right, to balance out the -1 charge for nitrate. If I had something like H2SO4, SO4 is sulfate, which means this would be sulfuric acid in this particular case. The reason we do have two of the hydrogens here is we need two H pluses to balance out the -2 charge that comes from the sulfate. So it has no effect on the name. The two in front after the hydrogen is still sulfuric acid, but that again is balancing it out. Again, acids can be thought of as ionic compounds, positive guy H plus, negative guy, whatever it may be, put together to equal 0 when you write the formula. Any questions on that there? So look at some of this here. We have hydrofluoric acid, hydrochloric acid, hydrobromic acid. And these are our guys there with some oxygens. So why don't we try some of these here? Actually, we just did that one. So why don't we try HF? Let's do HClO4. Let's do H2S. Let us do H2CO3. And let's do H3PO3. All right, so let's do some names on these guys, see what you come up with. I want you to write some formulas for hydrobromic acid. And let's do sulfurous acid. We'll do chloric acid. One more. Okay, let's take a look here. So starting with the first one, we have HF. So I see it's an acid. I see there's no oxygen. So this should be hydro. Middle guy is going to be fluoric acid. The hydrofluoric acid. I take a look at the next one here. I do see an oxygen, which means this is a polyatomic ion. And that's what I want to identify. That is Cl(O4 minus, which is perchlorate ATE. We actually do keep the per here when we go to the acid name. So this would be perchloric acid. I see. Again, no hydro here because it has oxygen, so we don't use it. Any question on those two there? Coming to the next one here, we do not see oxygen, so that is going to be our hydro beginning. That is going to be sulfuric acid. So hydrosulfuric acid, as we have the hydro and the ick for this guy that has no oxygen. Coming to this guy down here, that is CO3 2 minus, which is carbonate, ATE. So 8 is going to become ic. So this will be carbonic acid. Lastly, here in terms of the naming part, we have this guy, which is actually PO3 3 minus. That is phosphite, ITE, which means that this would be phosphorus acid. Any question on any of those names there? Yeah. On this one? Because it contains oxygen. So if it contains oxygen, it won't have hydro. So hydro is only for acids with no oxygen. Yep. Yep. Other questions? Okay, so let's take a look at the names if we want to kind of go to formula. So I'm just going to rewrite them, I think, on the next page, maybe. So I had sulfurous acid. I had hydrobromic. And I had chloric, I think. All right, so if you're kind of going from the acid name back to the formula, you can kind of follow our rules here. So the first one, when I look at it, I do not see hydro in the name, so I know it has oxygen, which means it should be a polyatomic ion, which means if I go to this part, that is OUS, which comes from ite. So if I kind of get rid of the last part of the name there, that is sulfite. ITE is really where it comes from, which is SO3 2 minus. Remember that all acids, the cation is H plus, so it's always H plus. So once again, we're going to balance this out to give us 0 charge. So we need one more of the H plus here, and that's going to get us to H2SO3 as our sort of formula. Any questions on that? Yeah. The H plus is always the cation or the positive guy in an acid. So always H plus for anything that's an acid. The positive guy is always H plus. And basically, you treat it like an ionic compound. So again, we want to get to 0. So because the sulfite had a -2, that's why we needed 2 of the H's there to balance that. Other questions? All right, so coming here, we do see hydro, which means it is an acid that does not contain oxygen, which means it's just a regular element here. So we can figure out bromic is bromide. And that means, again, the H plus is our cation. The Br minus is our anion. So when we put it together here, we get the HBr. Just need one of each. Any questions on that one? Lastly, here we have chloric acid. So once again, I do not see hydro in the name. So that tells me it has oxygen and a polyatomic ion. So once again, I could kind of just take the last part of here and get rid of the ic and replace it with 8. And that will tell me really my polyatomic ion is chlorate in this case. And chlorate in this case is CO3 minus. Once again, the H plus is our cation. So in this case, we actually just need one of each of those to balance it out. And that would get us HClO3 in this case. Question on how to name acids or write formulas. So from the name of the acid, just kind of work your way backwards. And, for those guys that do contain a polyatomic ion, you could get rid of the OUS or the ic and put the 8 or ite back on. You can pretty much figure out what the name of the polyatomic ion is. And then you just want to, again, put it together so that it equals 0. Any questions on any of the naming we talked about? That should take care of all the naming, I think, at this point. Any questions? Okay.